the vastness of space where light itself takes years to travel, our machines wander on our behalf, fragile, silent, and endlessly patient. Among them, one stands apart. It has no cutting-edge design, no modern computer chips, and yet it has done what no other has achieved. For 45 years it has sailed beyond every planet we know, carrying a small piece of who we are. Its name is Voyager. Today, let's journey together to uncover how this humble machine, built in the age of cassette tapes and analog dials, became the greatest explorer in human history. Let's learn how it keeps going, not because of luck or miracles, but because of the brilliance, foresight, and quiet determination of those who built it. This is Voyager, the machine that outlived time. In the endless dark, beyond the planets, a lonely machine is still whispering home. Its computer is weaker than the one in your car key. Its memory smaller than a single image on your phone. Yet somehow, after more than 45 years, it's still alive, still talking to us from the far edge of the sun's reach. That machine is Voyager 1, a relic of the 1970s that became humanity's farthest messenger. There's a strange irony in that, isn't there? While new spacecraft come and go, this old probe, built before the internet even existed, continues to send us discoveries from beyond the known frontier. Why has it lasted this long? What secrets lie inside a machine older than most of us watching today? Let's take a journey together across time, across distance, to understand how Voyager was built to outlive everything we've ever made. Voyager 1 and its twin Voyager 2 were launched in 1977 at a time when disco was still popular and computers filled entire rooms. Yet these two small spacecraft achieved what no other had done. They became the first human-made objects to enter interstellar space. Today, Voyager 1 is over 23 billion kilometers away. A radio signal from NASA takes more than 21 hours to reach it and another 21 to return. Imagine sending a message and waiting almost 2 days just to hear a reply. That's how far our voice has traveled. And even across that distance, its faint signal still arrives, weaker than the light from a fridge bulb, but clear enough for scientists to decode. It's astonishing that a 3.7 metre antenna powered by technology older than the World Wide Web can still be heard through the noise of the cosmos. Voyager's story began with modest goals. Each probe was built for a 5-year mission, just long enough to visit Jupiter and Saturn and study their largest moons. But the engineers at NASA's Jet Propulsion Laboratory had acquired vision beyond those two worlds. They designed the probes to last far longer than their official timeline, adding redundant systems, radiation protection, and software that could be reprogrammed in flight. It was a gamble, but it worked. After Voyager 1 completed its encounters with Jupiter and Saturn, and Voyager 2 visited Uranus and Neptune, NASA decided to push them both further still into interstellar space itself. This final phase, called the Voyager Interstellar Mission, would study the edge of the sun's influence, the termination shock, the heliosheath, and finally the heliopause, where our solar wind meets the deep interstellar medium. What began as a short journey became the longest scientific expedition in history. At the core of Voyager's longevity lies its power source, a radioisotope thermoelectric generator, or RTG. It converts the heat from the radioactive decay of plutonium-230 into electricity, a slow, steady heartbeat that has kept Voyager alive for decades. At launch, the RTG produced about 157 watts, enough to power a laptop and charge a phone. Each year the power output fades slightly as the plutonium cools. It will drop to half strength after roughly 88 years. It's a humble amount of energy, but in deep space efficiency matters more than abundance. That slow radioactive ember has been burning since 1977, and it's expected to last at least until 2025. By then Voyager will have been operating for nearly half a century, a machine whose life was measured not by years, but by atoms. Voyager was born in a rare cosmic window. In the late 1970s, all 4 outer planets, Jupiter, Saturn, Uranus and Neptune, were aligned in such a way that a single spacecraft could visit them all using gravity assists. This lineup happens only once every 176 years. NASA had one chance to seize it. Missed that window, and no one alive would see it again. With a tight deadline and limited funding, the team built 2 probes in record time. Each planet's gravity would slingshot Voyager faster, carrying it to the next world without using extra fuel. It was a perfect plan, a cosmic chain reaction that would fling humanity to the edge of the sun's domain. Voyager's success wasn't just luck, it was engineering foresight. Each spacecraft carries 11 scientific instruments, many with built-in backups. It uses 16 small thrusters, including 8 spares that sat dormant for nearly 4 decades until NASA woke them in 2017 and they worked flawlessly. Its systems were designed for autonomy long before AI was a buzzword. Voyager's computers could detect faults, restart subsystems and reorient the spacecraft on their own. Its navigation relied on gyroscope star trackers and a control computer, the Attitude and Articulation Control Subsystem, or AACS, which constantly keeps its antenna pointed toward Earth. When you consider that its transmitter has the power of a refrigerator light bulb, the precision is nothing short of miraculous. Lose that orientation and Voyager would vanish into silence forever. Every image, every discovery Voyager sent back travelled across billions of kilometres through that fragile radio link. Its 3.7 metre dish beam must stay perfectly aligned with NASA's Deep Space Network on Earth, a collection of giant antennas spanning 3 continents listening for the faintest whispers in the dark. Voyager also carried a digital tape recorder, a remarkable device for its time capable of storing about 100 photos. It used magnetic tape, the same kind found in 8-track cassettes, to buffer data before transmitting it back to Earth. Idetics, the company that built it, claimed the tapes could survive over 4,000 kilometres of wear without degrading, and they did. For decades, those tapes spun faithfully, enduring radiation, cosmic rays, and the cold vacuum of space. In time, the recorders were shut down to save power, but not before preserving a visual legacy of humanity's first tour of the outer planets. When Voyager launched, many scientists feared that the asteroid belt between Mars and Jupiter would destroy it. At the time, we imagined the belt as a chaotic minefield of flying rocks. In truth, it's mostly empty space. Voyager 1 and 2 crossed the region safely, teaching us that the belt isn't the dense death trap of science fiction, just another vast, quiet frontier. It was the first of many myths Voyager would rewrite. Beyond the orbit of Neptune, sunlight is 900 times weaker than on Earth. Temperatures plunge to extremes that no spacecraft had ever endured before. To survive, Voyager relies on heaters to keep its instruments warm. But as power output faded, NASA had to make choices. One by one, the heaters were switched off. 2 years ago, the heater for Voyager 1's cosmic ray detector was turned off, and its temperature dropped by 70 degrees Celsius. Everyone expected it to fail. It didn't. Even frozen in the dark, the detector kept working perfectly. 45 years after launch, this tiny machine continues to defy the laws of probability, and maybe a little, the limits of human imagination. In 2022, something strange happened. Voyager 1 began sending back garbled telemetry lines of zeros and nonsense data. For a moment it seemed as though it had lost its sense of direction. Yet the spacecraft was still alive. It was still responding to commands. Engineers soon discovered the culprit, a failing computer inside the Attitude Control System. By rerouting commands through a backup, they restored normal communication. It was a small victory, but it carried an unspoken truth. Someday there will be no backups left. When that day comes, Voyager will fall silent, its signal fading into the cosmic noise. And yet, even then, it will continue drifting outward, a silent witness still carrying the voices of Earth on its golden record. Voyager has travelled farther than any object humanity has ever built. Its discoveries reshaped our understanding of the solar system, from Jupiter's violent storms and active moons to Neptune's supersonic winds. But its greatest legacy isn't scientific, it's human. Voyager proved that with careful design and a little courage, we could reach beyond what seemed possible. A new mission is already being proposed, an interstellar probe that could launch in the 2030s and reach interstellar space in just 15 years. It will be faster, smarter, and more powerful than Voyager, and yet by the time it arrives, it too will be old. That's the nature of deep space exploration. Every mission begins as the future and ends as a time capsule. There's something poetic about an old spacecraft still working in the dark. Each day its fading pulse reminds us that time doesn't erase purpose, it defines it. When we look at Voyager, we don't just see metal and circuits, we see intention, the fingerprints of the engineers who built it, the curiosity of a species that refused to stop reaching. Perhaps one day, long after Earth has gone quiet, Voyager will still be out there, a faint echo of what we once were. It may be ancient, but it's still doing exactly what it was meant to do, to explore, to endure, and to remind us that even the simplest tools, when built with care, can outlive time itself. Somewhere beyond the edge of the sun's light, Voyager continues to drift, a tiny spark carrying our voice through endless night. Its signal grows weaker each year, but it's still there, a faint reminder that even in silence, we can still be heard. When its final transmission fades, it won't be an ending. It will be a continuation, a message written across the stars that says we were here, that we dared to reach beyond our sky. Voyager will keep travelling long after we're gone, our oldest ambassador moving through eternity. And maybe somewhere out there someone will find it and know that humanity once looked up and chose to explore. Thanks for watching. You've been with Cosmic Compass. Until next time, let's keep navigating the cosmos together.